All right, welcome. Today, we're going to put on our detective hats and solve one of the biggest mysteries of our time. We're sifting through planetary scale evidence to figure out what's really causing our climate to change so dramatically. Okay, let's get into it. So this is the question, right? It's really the heart of our whole investigation. And you know what? It's a fair question. The Earth's climate has swung from being a hothouse to an icehouse, and back again, way before we ever showed up. But there's something about what's happening right now that has scientists, well, pretty alarmed. Our job today is to figure out exactly what that something is.
Every good investigation starts at the scene of the crime, and in our case, the scene is the entire planet. What we're seeing isn't just a little bit of warming, it's more like a rapid, globally synchronized fever. Think about that. Over 98% of the Earth's surface is warming up at the same time, which is something that hasn't happened in at least the last 2,000 years. The sheer speed of this change, that's our first major clue.
Now, to solve this case, we have to do our due diligence. And that means we need to investigate the usual suspects. The powerful natural forces that have always been in the driver's seat when it comes to Earth's climate. If we can rule them out, then we'll know something totally new is at play.
Okay, so our first suspect is a big one, the Earth's orbit itself. These long, slow wobbles are known as Milankovitch cycles, and they're basically the pacemakers of our ice ages. For millions of years, they've set the rhythm of our planet's climate just by shifting how sunlight hits us.
So the big question is, where are we in that cycle right now? Well, based on Earth's current position, we should be in a very slow, very gradual cooling phase. We should be inching our way toward the next ice age over thousands of years. But instead, temperatures are shooting up. We're literally going in the exact opposite direction. So suspect number one has a rock-solid alibi. Case closed on that one.
All right, if it's not the Earth's orbit, what about the giant fusion reactor in the sky? The sun is the engine of our whole climate system, so it's the most obvious suspect to check next. Maybe it's just, putting out more energy lately.
This is where our modern tech really helps the investigation. We've had satellites measuring the sun's energy with incredible precision since 1978. And the data? It's crystal clear. There is no upward trend. In fact, solar activity has actually gone down slightly since the 1950s, all while our planet has been warming faster than ever. So nope, the sun is not our culprit.
And this leads us to a really fascinating piece of evidence. A clue that isn't just about how much heat is arriving, but where that heat is getting trapped in our atmosphere. This clue isn't just going to clear the sun for good, it's going to point us directly towards the real cause. Okay, on to our third natural suspect, volcanoes. We all know they pump stuff into the atmosphere, but to investigate them properly, we need a sense of scale. Every single year, we're seeing an injection of over 35 billion metric tons of carbon dioxide into the atmosphere. So the key question for our investigation is, can volcanoes account for a number that huge?
So when we compare that 35 gigaton number to all the volcanoes on Earth combined, both on land and under the sea, the difference is just staggering. All of global volcanism puts out about 0.3 gigatons of CO2 a year. Human activity? We release more than 100 times that amount. So while volcanoes definitely affect the climate, there's just no way they can account for this massive increase we're seeing. Suspect number 3 is cleared.
So let's recap. We've ruled out the planet's orbit, the sun, and volcanoes. All the usual natural suspects have alibis. So our investigation now turns to a new suspect, which means we need to look for definitive proof. The kind of forensic evidence that really holds up. We need to find the fingerprints. And guess what? We have it. This is basically the DNA evidence of our climate case. It's called the Suess effect, and it involves looking at different types or isotopes of carbon atoms in the air. This chemical analysis lets us trace the extra CO2 back to its specific source, kind of like a forensic chemist. It's pretty cool. So here's how this chemical fingerprinting works. It's actually pretty straightforward. Plants, well, they prefer a lighter type of carbon, called carbon-12. And fossil fuels are just ancient plants, right? So they are full of this lighter carbon. They're also millions of years old, so any radioactive carbon-14 they might have had has completely decayed away. So when we burn fossil fuels, we release a flood of CO2 that has this really specific signature, less carbon-13 and absolutely zero carbon-14. And that is exactly the shift scientists are measuring in the atmosphere. It's a direct chemical match, the smoking gun.
But wait, there's a second fingerprint. Remember that clue about where the atmosphere is warming? Well, if the sun were getting hotter, it would heat our atmosphere from the top down. Every layer would get warmer.
But if the warming is caused by greenhouse gases, you'd see a totally different pattern. They trap heat down low, near us, which actually prevents that heat from reaching the upper atmosphere.
And what if our satellites confirmed this exact pattern? While the lower atmosphere is warming up, the upper atmosphere, the stratosphere, is actually getting colder. This pattern is the unmistakable signature of the greenhouse effect in action. It's physical proof that rules out the sun and confirms that heat-trapping gases are the culprit.
Okay, so we've established the culprit on a global scale, but what does this actually look like on the ground? Let's zoom in on one specific place, Sweden, to see the tangible, real-world impacts of this planetary change.
What's happening in Sweden is basically a supercharged version of the global story. The country is warming at roughly twice the global average. Just think about that. Compared to a few decades ago, the average temperature is up by nearly 2 degrees Celsius. That means more rain, longer growing seasons, and way fewer days with snow cover each year. And these aren't projections for the future. These are observed changes that have already happened.
And this data translates into some pretty dramatic shifts in the ecosystem. In the Swedish mountains, trees are now growing where they simply couldn't before. The tree line is moving uphill at a pace of about 1 meter every single year. It's like a slow-motion migration that's squeezing out the unique alpine ecosystem as it goes, all driven by this rapidly changing climate.
So, the evidence has been presented, the alibis have been checked, the fingerprints have been analyzed. It's time to bring all the threads of our investigation together and deliver the final verdict.
Let's look at the case file summary. The motive, the energy that fueled our modern world, the natural suspects, the planet's orbit, the sun, and volcanoes, all have clear, verified alibis. And we have 2 undeniable sets of fingerprints, that unique carbon isotope signature in the air and the cooling of the stratosphere. The result is a planet warming at a rate that's just off the charts, moving 170 times faster than the natural cycle it completely overpowered.
You know, this mountain of evidence, coming from all these different independent fields of science, is why there is such an overwhelming consensus among climate experts. A huge review of over 88,000 climate-related studies found that more than 99.9% of them agree that humans are causing the climate change we're seeing. This isn't a hunch. It's the conclusion drawn from all that evidence. So, the mystery is solved. We've investigated the suspects, we've found the fingerprints, and we know not only that the climate is changing, but why. The scientific investigation has delivered its verdict. And that, well, that leaves us with a much bigger, much more urgent question that science alone can't answer. What do we do now?